Namaste dear students. In the last few classes we were discussing about mean deviation, isn't it? So mean deviation means it is the third measure of dispersion. So dispersion is the property of it is calculating the deviation of observations from their central value. So central value, from central value how much each deviations are deviating, each observations are deviating, isn't it? So we saw first one range, next quartile deviation. Range based on only extreme values. Quartile deviation means middle to 50% observations we are considering, remaining 50%, first 25 and last 25 we are ignoring in quartile deviation. They are the demerits of range and quartile deviation. To overcome that demerit, a third measure of dispersion was introduced. One more demerit of range and quartile deviation is it is not based on all the values, and one more it is not measuring in terms of any measure of central tendency. We are not taking deviation from any measure of central tendency, isn't it, in the case of range or range and quartile deviation. So third measure of dispersion, that is mean deviation, was introduced. The mean deviation is based on all the values, and mean deviation we can compute from mean, median or mode. So we were discussing continuous problems, continuous frequency problems. So the continuation of that only, we will do some more problems, so that the concept will be more clear to you. So next see, compute, next question, compute mean deviation from mean and median. Both we have to compute. Compute mean deviation from mean and median. See, this is the thing, age in years given, number of persons. Remember one thing, read the question clearly. So it is greater than 0, greater than 2, greater than 4, greater than 6. So what are given here? Greater than 0 means greater than 0, greater than 2, greater than 4 means we can conclude that the width is how much? Width 2, isn't it? 2 here, like that. So greater than 0 means 0 to 2. These are the lower limits. Greater than 0 means 0 is the lower limit. Greater than 2 means 2 is the lower limit. Greater than 4 means 4 is the lower limit. Greater than 6 means 6 is the lower limit, isn't it? These are which one? These are not frequencies, remember. So if here lower limits given means here more than cumulative frequency will be there. More than cumulative frequencies are given. First we have to convert, if such a problem is there means first we have to convert that into class interval and frequencies. Next we have to compute the problem, isn't it? So take this one itself a solution. See, age is actually class interval. Then number of persons actually it is MCF, more than cumulative frequency here, but here I am taking frequency I have to convert this as a class interval and frequency, then only we have to do the problem. See, next mean deviation from mean itself. So we can do the mean and median, both we have to compute. We will do in one problem itself or one table itself. So construct the required columns for that, then we will do, no problem. Before that, first we will convert it into class interval and frequencies. See, greater than 0 means 0 to 2, greater than 2 to 4, greater than 4 to 6, greater than 6 to 8. So how I came to know that class interval is 2? Just see all the width or all the differences you see, greater than 0, next greater than 2, greater than 4, so that we can conclude that width equal to 2. Next, first frequency, actually these are not frequencies, I told, these are more than cumulative frequencies. First convert it into frequencies. More than cumulative, greater than 0 this much observations are there, greater than 2 this much observations are there. So first frequency won't be 20, it is 20 minus 15, that is 5. Next 15 minus 7. 15 minus 7 is 8. Next 7 minus 3. 7 minus 3 is 4. Last frequency remains same. See, in the case of if this is lower limit and more than cumulative frequency, in such case last frequency will be same. If ulta given means which one? Here less than cumulative, upper limit and less than cumulative frequency is given means first frequency will be same. Idra just ulta adre first frequency same irtade. This is upper, here lower limits given, lower limit kotre last frequency will be same. Next same as usual what we are doing. First we have to compute mid x. Next one column for f into x. That is for finding x bar. Next less than cumulative frequency is required to compute median. To compute median less than cumulative frequency is required. Next one column for mode x minus x bar, absolute deviation. Next f into mode x minus x bar. Next mode x minus median. Last f into mode x minus median. This much is there. We have to compute. See, this is just based on formula. If you remember the formula means there is no difficulty in doing the tables. See, first we have to compute mid x. Mid x means 0 plus 2 divided by 2. Upper limit plus lower limit divided by 2. 0 plus 2 divided by 2, 1. 2 plus 4 divided by 2, that is 6 by 2. 4 plus 6, 10. 10 divided by 2 is 5. 6 plus 8, 14. 14 divided by 2 is 7. F into x. F into x, 5 ones are 5. 8 threes are 24. 4 fives are 20. 7 threes are 21. Correct na? Next first we will go through mean itself. Next we will go to median. I will find mean here. So total required. Total which one? This frequency is required. Capital N how much? Capital N will be this one itself, 20 itself. If you count, no problem. 8 plus 5, 13, 17, 20. Correct na? Sigma fx. Sigma fx means this total. Sigma fx total is 70. Okay. Next, first compute x bar. I will write here only. See, mean x bar equal to sigma fx divided by capital N. Sigma fx divided by capital. Sigma fx is 70, capital N is 20. So it is 70 divided by 20. Answer is 3.5 it seems. 3.5. Correct na? 3.5. Next what we have to do? We have to take deviation from absolute deviation from each observations. Mode x minus, this one I will do later. This is for finding median. This column and this column I will complete first. X minus x bar. X is mid x. 1 minus 3.5. We have to take absolute deviations. So don't put the sign. 1 minus 3.5 is actually minus 2.5 plus, but we are taking only 2.5 because we are now taking into consideration the sign. Next is 0.5, that is 3 minus 3.5. Next 5 minus 3.5, 7 minus 3.5, like that. 0.5, next 1.5, next 3.5. X minus x bar, 3 minus 3.5. Correct na? See, 1 minute. 3 minus 3.5. 3.5 itself. Okay. Next f into mode x minus x bar. X minus x bar is this much itself. Next f into mode x minus x bar. F into mode x minus x bar is 5 into Yes, correct. Okay. X minus x, 7 minus 3.5 is 3.5 itself. Sorry, I thought this one actually, correct. 7 minus 3.5 is 3.5 only. Next term, f into mod x minus x bar, that is which one? This column, second column into this column. 5 into 2.5, 8 into 0.5, 4 into 1.5, 3 into 3.5. See, I will write the answers only. 12.5, 12.5, next 4, next 6, next 10.5, 10.5. Clear na? F into mod x minus x bar. This total is required to compute our mean deviation from a mean. So, it is a 12.5 plus 4 plus 6 plus 10.5. F into mod x minus x bar is 33. I will write here only mean deviation from mean equal to mean is x bar, sigma f into mod x minus x bar divided by capital N. This total divided by capital N. Capital N is 20. 33 divided by 20. Answer is 33 divided 1.65. 1.65. Clear na? Nothing here. First we have to compute mid x. Next which one? F into x into x minus x bar. X minus x bar. Actually absolute deviation. So we are ignoring the sign here. Next f into mod x minus x bar. It's the total. Then divided by capital N. Correct na? Next we will go to median. We have to find a median. So, median, to find median, first we have to compute less than cumulative frequencies. So, first frequency, don't take this and all, again we have to go for frequencies itself. Frequency, first frequency 5 itself. Next 5 plus 8, 13, 13 plus 4, 17, 17 plus 3, 20. Correct na? This is less than cumulative frequency. Next we will find a median. I will write here. So, median equal to find median, capital N. Capital N is 20, N by 2. N by 2, 10. LCF just greater than or equal to 10 is 10 ಗಿಂತ just greater ಇರುವ cumulative frequency. Go to the less than cumulative frequency just greater than 10. How much? 13. Corresponding class. Corresponding class is 2 to 4. It is 13. 2 to 4 is a median class. Median class. Next, L means lower limit of median class. F means frequency of median class. Frequency of median class is 8. 2 to 4 is median class. 8. LCF is 5. 8 CF 5. C equal to width of median class, that is 2. Median equal to, apply the formula L plus N by 2 minus CF into C divided by F. C, apply the formula, substitute the values. The answer is 3.25. Median equal to 3.25. 3.25. That is a median. Median equal to 3.25. Next what we have to do? Yes, we have to go to x minus m. Mod x minus m, or it is, we are taking the absolute deviation, so that we have to ignore the signs. So, x minus m, x is midpoint. 1 minus 3.25, 3 minus 3.25, 5 minus 3.25, 7 minus 3.25. All these are absolute deviation, so we are ignoring the signs. So, just answer I will write 2.25. Next one is 4. Next 6. Sorry, x minus 2.25. This is 0.25. Okay, 0.25. Next one is 1.75. Next one is 3.75. F into mod x minus m. F into mod x minus n is 11.25. Next one is 2. Next 7. Next 11.25. This total is required. This total is 31.5. 31.5. Next again apply the formula to find mean deviation from a median. What is the formula? Yes, mean deviation from median is sigma f into mod x minus m divided by n, isn't it? See, I'll write here, I'll rub this one. So, mean deviation from median equal to sigma f into mod x minus m divided by capital N. That is sigma f into mod x minus m is 31.5 divided by n is capital N is 20. Answer is 0.48. See, from this problem also you will come to know that the minimal property of a median. So, mean deviation is least when it is measured from a median. So, compared to mean deviation from median is least. This is called the minimal property of a median. So, in the problem if they didn't mention which measure of central tendency, you have to compute mean deviation from median itself. Clear na? Yes. So, we will do one more problem. This one greater than 0 greater than 2 means lower limit and more than cumulative frequency given. Same upper limit and less than cumulative frequency given. What is how to do? We will do one problem. Hope this one clear. See, if you know the formula, just construct the columns required to that and apply the formula. Nothing is here. Only the thing you have to remember is we are taking the absolute deviations. So that we have to ignore the signs. Sign won't be there. So, next problem, we will go to next problem. Compute mean deviation. Compute mean deviation. So, suppose data is given about lower limit, upper limit and less than cumulative frequency. Okay. So, compute mean deviation. Second question, compute mean deviation. See here, they just told compute mean deviation. They didn't mention from which measure of central tendency we have to take. So, such a problem I told earlier, we have to take mean deviation from median itself. Correct na? See, and it's a coefficient. Coefficient also you can do. Monthly income, number of persons. Monthly income and number of persons. Monthly income less than 5,000, less than 5,000, less than 6,000, less than 7,000, less than 8,000, less than 9,000. Next, less than 10,000. Okay, here number of persons 5, 13, 23, next 32, 38, next 40. Okay, so what is the difference between this one and earlier problem? Yes, here less than 5,000 means 5,000 is coming as upper limit. Less than 7,000, 7,000 is coming as a upper limit, isn't it? All these given are upper limits. Then what will be this one? Number of persons means they are not frequencies. Remember, if here this is upper limit means these are less than cumulative frequencies. So, if upper limit comes means together less than cumulative frequency will come, and if more than or lower limits are given means more than cumulative frequencies will come together. So, first convert it into class interval and frequencies, then do as usual. So, solution, okay, I will write here only, much space is required for such problems. See, income, I will write income, class interval, okay. Actually, you have to write as it is in the problem, and you have to write the units for the first one. Units everywhere you have to write where it is independent, coefficient is independent of units, all other contains units. So, class interval and frequencies itself I will write. Next, compute the or construct the columns required to that. First, less than 5,000, less than 6,000, less than 7,000. See the difference by seeing the problem, the difference is 1000 or width is 1000. So less than 5000 means 5000 is coming as a upper limit, isn't it? So it is 4000 to 5000, next 5000 to 6000, similarly 6000 to 7000, 7000 to 8000, next 8000 to 9000, next 9000 to 10,000. There 10,000 is coming as a upper limit. Clear na? See, these are not frequencies. Again I am repeating, these are less than cumulative frequencies. So for finding median, less than cumulative frequencies are required. We have see here, first frequency will be same 5 itself. Next frequency 13 minus 5, that is 8. 23 minus 13, 10. 32 minus 23, 9. 38 minus 32, how much? 38 minus 32 is 6. Last 40 minus 38 is 2. Correct na? 5, 8, 10, 9, 6, 2. Clear na? Next, once we found this much means next problems are same. Next the method is same. First we have to find, these are compute mean deviation means we have to find median. To find median, same will be there. 5 plus 8, 13. 13 plus 10, 23. 23 plus 9, 32. 32 plus 6, 38. 38 plus 2 is 20. Sorry, 38 plus 2 is 40. Correct now? Yes. Next we have to find median. I will write median here. Median equal to capital N. Capital N is 40. N by 2 is 20. LCF just greater than or equal to 20 is 23. Corresponding class is 6000 to 7000. 6000 to 7000 is our median class. Next, L means lower limit of median class. Correct na? F means frequency of median class. Frequency of median class is 10. Cumulative frequency just above the median class is 10 in a corresponding cumulative frequency. Adra just mudlirvadu. How much? It is 13. C means width. C equal to 1000. Then apply the formula. I will write the formula. Median equal to L plus N by 2 minus CF into C divided by F. CL is a separate term. So first we have to do the this much. Next we have to add L. So answer is median answer is 115. Sorry, median is 6700. 6700. Hope it is clear. You know how to find a median in the continuous series. Same here we did. Next mode, sorry, x is required. Mid x. Next mode x minus m. Next f into mode x minus m. Correct na? Mid x. Mid x means upper limit plus lower limit divided by 2. 4000 plus 5000 divided by 2. 5000 plus 6000 divided by 2. 6000 plus 7000 divided by 2. 7000 plus 8000 divided by 2, like that. Here 4500, 5500, 6500, 7500, 8500, 9500. Correct na? Next, x minus m, absolute value. So 6700 is our median. So mode x minus m is 4500 minus 6700. That is answer is 2200. Next one is 1200. Next one is 200. Next 800. Next 1800. Last one is 2800. Last column is f into mode x minus m, where f into mode x minus m is x minus m this much, x is this one, f into x into x minus m is this, f is this one. 5 into 2200, 8 into 1200, 10 into 200, 9 into 800, 6 into 1800, 2 into 2800 you have to do. See, I will write the answers only. First one 11,000, next 9,600, next 2,000, next 7,200, next 10,800, last one is 5,600. Its total is required to compute mean deviation from median, isn't it? Answer is 46,200. Next, apply the formula. Mean deviation from median equal to sigma f into mod x minus m divided by capital N. Sigma f into mod x minus m, how much? 46,200. 46,200 divided by capital N. Capital N is 40. Correct na? 46,200 divided by 40. Answer is mean deviation is 1155. 1155. See, that is that much rupees. You have to write the units because this is income. Income given in rupees. So 1155, that much rupees. So that is mean deviation from a median. So hope it is clear with the concept mean deviation. So mean deviation is least when it is measured from a median. That is called the minimal property of a median. So we computed mean deviation from mean, mean deviation from median, mean deviation from mode in the case of raw data, discrete series and continuous series, isn't it? Next, just go through the merits once again. See, now it is clear mean deviation. Once you know mean deviation, once you know the problems also, it is clear. What are the merits here? Yes, merits means it is based on all the values. It is rigidly defined by a mathematical formula. What are the demerits here? See, demerits, one demerit means here we are ignoring the sign, isn't it? Here we are ignoring the sign, we are taking absolute deviations here. So it is one demerit of mean deviation. Then mean deviation is least when it is measured from median. But in measure of central tendency, which is the best measure of central tendency? Yes, it is arithmetic mean. Arithmetic mean is considered to be the best measure of central tendency. But mean deviation is least when it is measured from median. So median we won't consider as good as arithmetic mean, isn't it? That is one demerit of this one. But all others, it is bit good. We are ignoring absolute sign here. We are taking absolute deviation. That is one demerit of this mean deviation, isn't it? So we will continue in the next class with the standard deviation. One more measure of dispersion, which is the best measure of dispersion, that we will continue in the next class. Thank you.